Now, energy of the dipole. Energy of an electric dipole. Okay, when placed inside a uniform electric field. When dipole is placed inside a uniform electric field, then what is the potential energy of the dipole? So we know we have, say for example, a dipole is twisted to an angle theta when it is placed inside the uniform electric field. Say, if it is uniform electric field, a dipole is twisted to angle theta when it is placed inside the uniform electric field. Okay, so theta is the displacement. Okay, means theta displacement when dipole is placed inside the uniform electric field, then it is displaced to a distance that is d theta. Okay, d theta is the displacement when dipole is placed inside the uniform electric field. So we know that when dipole is placed, a torque come in play, and that torque rotates the dipole. Due to that torque only, the dipole is changing its orientation. So dipole is displaced by theta angle due to torque. So we can use torque as a force and d theta as displacement. So work done, we know that work done is equal to force into displacement level. Now what is the force when dipole is placed inside the uniform electric field? Torque. So we can write torque into displacement. Torque is acting as force, and force into displacement is work done. Now what is displacement? D theta is the displacement. So we can write d theta. Okay, d theta is the displacement. So torque into displacement, that is angular displacement. Okay, because the dipole is rotating, so in rotation we have to consider displacement, that is angular displacement. So we are writing torque into rotating force into angular displacement. So this is work done. So now what happens? This is small work done. We can say dW is equal to torque d theta. Okay, now what if the dipole is rotated from theta 1 to theta 2? Okay, from theta 1 to theta 2. Okay, what if the dipole is rotated from theta 1 to theta 2? What is the total work done? So total work done, we can write W is equal to integration theta 1 to theta 2 of this small work done, that is dW. Okay, got my point? Now we can write W is equal to integration dW. dW is torque d theta. Now what is the value of torque? In the previous topic we have learned torque is equal to E P sin theta d theta. Okay, now see, this is the integration theta 1 to theta 2 W. Now W is equal to EP sin theta, EP integration sin theta d theta, theta 2 theta 1. Okay, got it? Now what is the integration of sin theta? Sin theta is minus cos theta. So we can write EP is under bracket minus cos theta, upper limit minus lower limit. What is upper limit? That is theta 2 and theta 1. Upper limit minus lower limit. So we can write EP cos, upper limit is theta 2. So we can write theta 2 minus cos theta 1. Okay, and this is minus sign minus. Okay, this is negative. So this is the energy of the dipole. Now W is equal to work done, is total work done is equal to minus EP, okay, cos theta 2 minus theta 1. Okay, so this is the energy of electric dipole when it is placed inside the inside a uniform electric field, and this energy is known as a potential energy of the dipole. So potential energy of the dipole is equal to minus EP cos theta 2 minus cos theta 1. Okay. Now, if we discuss the case number 1, if the dipole is originated initially at 0 degree, initially at 0 degree means theta is equal to theta, initially at 0 degree. Okay, then what will happen? Cos theta 1 means cos theta 1 0 degree means u is equal to minus EP cos theta 2 minus 1. Okay, because cos 0 degree is equal to 1. What is the theta dipole is initially at 90 degree. Initially at 90 degree means initially it is making 90 degree angle with the direction of electric field. Then potential energy is equal to minus EP cos theta minus 0, theta 2 minus 0. Okay, or we can write it as u is equal to minus EP cos theta. Okay, so this is the two case we have discussed in case of energy of an electric dipole, when electric dipole is placed inside the uniform electric field. Okay, now next, what is the ratio of E electric field intensity axial to E equatorial? Okay, what is the ratio of this for an electric dipole? What is the ratio of the electric field intensity axial line and to electric field intensity at the equatorial line? What is the ratio? So if you find the ratio of E axial to, that is E axial divided by E equatorial, and the condition is the dipole is very short dipole. Okay, dipole is very short. Twice A is very less than R, means dipole is very short dipole. Okay, we are considering short dipole. Then what is the ratio of E axial by E equatorial? Then you will get 2. Okay, this is the concept. This is a small point. Please remember this point. The ratio of E axial to E equilibrium or E equatorial when the dipole is very short. If you consider a small dipole, twice is very less than R, then what happens? The ratio of E axial and E equatorial is equal to 2. Okay, so sometimes question may ask, what is the value of E axial if E equatorial is given for a small dipole? So we can easily use this formula to find the value of E axial or sometimes E equatorial. Okay, so remember this point and note this point because it is very important. Okay, thank you class. For today I conclude with this topic. Okay, in the next class we will study electric flux. Okay, next class we will study electric flux. Okay, till then, thank you, goodbye, take care.